Yeah. Okay. So today we're going to continue looking at the visualization capabilities of JMP. What did we do? The last thing that we did in the previous class. Can anybody remind me? How to save it. Yeah, that was. Which chart did we do? Which problem did we look at? Titanic, right? And we did visualization of two different variables. So it was a bivariate table and bivariate plot, right? So let's go ahead and finish off this example because I believe we didn't quite finish, right? So go ahead and open JMP. All right, so it should look like that. And probably in the list of files that we had before, there should be a Titanic, right? So go ahead and double click on Titanic so that it will open up. So as we discussed in the previous class, this is a simplified version of the file, right? It has all passengers, 2,200 and one passenger. And each passenger has 4 variables, right? All the records have values for 4 different variables. And all these variables are nominal, right? Whether or not person survived, what was the gender, male, female, age. Age was adults versus children, right? And what class the passenger traveled. First, second, third, or crew. So what we said is we can actually slice and dice the data in a lot of different ways. One way to represent the data is 2 variables at a time. Because we look at 2-dimensional screen, so it makes sense, 2 variables at a time. So we're essentially investigating a categorical variable versus another categorical variable, right? Nominal versus nominal. So what we did, I believe, was this one, fit y by x. So we're going to quickly reproduce the analysis that we did, right? And here is the sort of a helping chart for me, right? It says your x can be either categorical, nominal, ordinal, or it can be continuous, right? Blue triangle. And your y can be either continuous or categorical. Well, in our case, everything that we pick is going to be categorical, right? So what we did is we said, we're going to plot the survived versus sex, right? Sex is x variable, survived is y variable, and when we click OK, we're going to get this analysis, right? So analysis at the top, essentially it's a graphical representation of our data, right? It's a mosaic plot, so it gives you the idea of, in the overall data set, what was the division, sort of ratio between people who survived versus people who died, and then same thing, statistics of people who survived and drowned for males and for the females separately, right? So what I believe we started to do is contingency table, right? Contingency table is a numerical summary of pretty much exactly what you see on the picture, right? Here, for example, right? 2201 is the total number of observations, right? Now, they can be sliced in 2 different ways. Out of them, some people died, some people survived, right? So here you go. Vertically, in columns, we have survived, right? So out of 2201 people, 1,490 drowned, and only 711 survived, right? Now, we can slice it in a different way. We can say, well, these 1,201 passengers, some of them were males, some females, right? So, how is the data set, how is it sliced by the gender? Well, here, right? We can see that 1,731 males and only 470 females. So, the Titanic was predominantly male ship, right? So, the passengers that traveled from England to New York, right? It was going to New York. I don't know where it was going. New York, yeah. Most passengers were males, right? And then we have combination of males, right, survived or not, and females, survived or not. Okay. Therefore, every cell in my table have the summary for that specific combination, right? So, for example, this one, females who didn't survive. The count was 126, and we discussed that this is your helping cell right there, right? It basically instructs you how to read the data inside of every one of these cells, right? So first one is count, physical count. 126 females didn't survive. And the second one is percentage out of the total. So these numbers, female survived, yes, no, and male survived, yes, no, they add up to everything, right? To 2,201. So that number, 126, represents 5.72% of all the passengers that were on Titanic, right? And obviously the second number in every one of these cells, if you add them together, what you're going to get? 100%, right? So all possibilities, male survived not, female survived not, that's basically 100%, right? Then number 3. Number 3 basically says it's the percentage in the column, right? So number 1, females, column, right? First column is survived no. That means that all people who drowned, right? And the count was 1490, right? Passengers who didn't survive the crash. Out of them, there were 126 females and also 1,364 males. So you can see that number of males is more than 10 times larger, right, who drowned than the number of females. So therefore, right there, okay, out of this number, 1490, everybody who drowned, females were 8.46%, and the rest of them, 91.54 were males, right? So if you add the third number in the column, you're going to get 100% again, right? The breakdown for the males was what? Survived, hold on. Yes, survived. The breakdown was 344 for the females and 367 for the males. Now you can see that actually, among the people who survived, the breakdown was close to 50-50, right? Approximately equal. Well, how exactly approximately? Females were 48.38% among those who survived, and the males were, well, whatever is left, right? 51.62%. So that's how you interpret the third number. And lastly, number 4. Let it go to the voicemail. Happens second time today. Somebody calls me on the cell phone in the middle of the lecture. Okay, anyhow. Number 4 is the percentage of row. In the rows we have genders, right? Females and males. So females, some of them survived, some of them didn't survive. But out of total 470 females, 126 survived, or no, didn't survive, which represents 26.81% of all females on the ship, and 344 survived, which represents 73.19. So if you add number 4 in each column in the row, you're going to get 100% again, right? Fairly straightforward. Any questions? How to interpret the contingency table and the corresponding mosaic plot? Everything clear? All right, cool. All right, so now let's go ahead and close this one. And I want to show you, and close the data set as well, okay? I wanted to show you another data set, SAT by year. So let's find it among the files, okay? So go to Help, Sample Data Library. By now you're familiar with this one, right? How to get the data files supplied with JMP. And among the files, go ahead and scroll down. Find the file that's called SAT by year. SAT as in the test that you take to get to the college, right? SAT by year. Yeah, right there. You find the file? Yeah. Okay, good. All right, so this file contains a lot of information, well, data I should say actually, about all 50 different states in the United States, and you can see that it's all educational related, right? For the most part. So these are the list of our variables, okay? So state is obviously what type of variable? What does that mean? Red triangle or red bars. Which type of variable? Nominal, right? Nominal. It's categorical nominal data because states are not ordered, right? Okay, and then there are two more nominal variables. Year, amazingly enough, you would think that year would be a continuous variable, but no, we treat that as nominal in this case for some reason. Weird. Okay, and region is basically, we're going to look at that actually, and the meaning of region is states, as you know, can be subdivided into groups, right? Southern states, Midwest, Northeast, etc., right? Mountain area. So regions are basically groupings of states. Okay, everything else is numerical. So what can we say about every state? Well, how much money they're spending. And sometimes, actually, when you create the data, you leave behind some comments. And the easiest way to see is basically hover your mouse and keep it steady on the top of the variable in the list of columns. And if something shows up, that's the comment. So expenditure, Nothing, right? So we can only guess. It's billions of dollars spent on public education, probably, in the state, okay? Students-faculty ratio, self-explanatory, right? All students divided by all faculty, there you go. Salary, also self-explanatory. Now, percentage taking, I believe there are some comments left behind, no? Percentage taken, at least yesterday I was able to... Do you see any comments? If you hover on the top of that? Okay, let's go into the column info. Yeah, I don't see any comments. All right. Percentage taking is basically the percent, I believe, of population of the state that took the SAT. Okay? X and Y, honestly, I have no idea what that means, so let's just skip it. Okay? Latitude and longitude, self-explanatory, right? Oh, look at that. There is actually some geographical data comes from maxmind.com. Okay. Percentage taking 1997. ACT scores percentage taking. And then we have, at the end, SAT verbal versus SAT math, right? So some educational data. So let's do this. Let's see what can we do with, how else can we represent the data. And let's start with line plot. Let me ask you this question. If I plot SAT math versus the SAT verbal score, am I expecting to see any patterns? Even before we do that. We'll do that in 2 minutes, but if I plot verbal score versus math score. So for each person I have 2 scores, right? When you took the SATs, you get your reading score and you get your math score, right? So if I treat one of them as X and another as Y, okay? What do I expect to see? Any guesses? Well, actually, let's not guess. Let's just go ahead and draw it, okay? So,
I would say like
no correlation? Yeah, let's take a look. So I'll go to the graph and go to the graph builder. All right. So it doesn't really matter which is Y and which is X. So let me go ahead and take SAT math as X and drop it into the X zone. And that's just a scatter plot, right? That's basically jitter. And SAT verbal, drop it into the Y zone. So, what do you think? Is there a correlation?
Yes.
There is a correlation, right? So what does it tell you? If you took an SAT and you scored badly on the math test, right, on the math part, how likely are you to score high on the verbal part? Not very much, right? And that makes sense, right? If I'm not prepared well for the SAT, well, I'm probably not prepared for both parts, right? And if I took the preparation course, or just, didn't need the preparation course, I'm a good student to begin with, and probably I'm good with both subjects, right? So the more you study, both scores come up, right? So there is a correlation. Okay, and if I want to see what kind of linear dependency is that, I can go ahead and click on that one, right? And it just basically plots me the straight line. So this is the line of the best fit. How do we call the line of best fit? Starts with R. Regression. Actually, probably in a month from today, we're going to look at the regression one more time. So you've seen regression before, I know that, because they all took BUS 231, right? But we're going to do it all over again, because regression takes a special place in the heart of any data scientist. Okay? So regression actually serves as the basis for something that's called logistic regression. And that's a little bit different animal, but still based on the regression analysis. That's why regression is so special for data analytics. Okay? All right. So this is fairly easy to do, right? Now let me go ahead and do a little bit different plot. So go ahead and click the button Start Over. Okay? So let's do something more advanced. Start Over. Start Over cleans out everything and it says, yeah, go for it, right? Okay. JMP has a capability of displaying maps, geographical maps, and that's really cool, right? So there goes. I have the variable that's called state, right? And variable state is basically, if I look at my file, Alabama, Alaska, Arizona, it's just names of states, right? So here's what I'm going to do. I'm going to grab the variable and drag it in this little square, which basically says map shape, okay? Map shape, and it displays the picture for you right there. And it's colored already, but I didn't ask for anything, right? So quite honestly, I don't know how it's colored. It's probably just random stuff. Okay, some states are blue, some states are kind of grayish, some states are red. So it's probably fairly random right now, because other than displaying a map, I didn't ask for anything, right? Okay, so let me go ahead and see what can I do with this. If I want to look at the ACT or SAT scores, say for example math score, okay, I'll just go ahead and scroll down to the bottom. So I want each state to be highlighted according to how highly or lowly they scored on SAT math, right? And that will tell me graphically, visually, which states are best, which states are worst, what's going on, okay? All right, let's go ahead and take the SAT math, and I'm going to just drop it in the bulk of the report, like that, on my map, and drop it on the top of my map. And then it highlights for me states on different shades of, well, it's kind of on the spectrum between blue and red, right? So, and there is a legend right there that basically tells you how to interpret. So, tell me what you see. Is it better to be in the blue state or in the red state? Red state, because red corresponds to high SAT math scores, right? So, ladies and gents, what do you see? Which states are doing the best in terms of math? Kind of states in the middle, right? If you look at the coast, East Coast or West Coast, doesn't matter, and Texas, and Alaska. Alaska is right there, right? What is that, by the way? Hawaii, right? So other than these states, kind of in the middle of the country, right, and some southern states probably are doing great, right? Everybody else is not doing all that hot, okay? Now, was that easy or what? It was easy, right? And it's kind of a nice way to represent things on the heat map, right? So according to the color, you can visually tell, even without knowing exact numbers, you can tell pretty much where things are going good and where things are not going so good, okay? All right, so let's go ahead and do this. What if I wanted to, this is my SAT math score, right? What if I want to see, for example, SAT verbal? How do I do that? Well, I can do something that's called column switcher. In other words, right now the map displays SAT math score and it's fixed, right? And look at that. Actually what happened, kind of I want to point out. Let me go ahead and start over. You don't have to start over, but I will, okay? So I'll do it again. I drop the state and then into the map shape. If I want to highlight states, just like I did according to the SAT math by color, what I did really is I took the SAT math and I dropped it in the bulk of the table, of my picture, right? Alternatively, I could just go ahead and put the color right here. Okay, there are a couple of zones here. It says overlay, color, size, etc. So if I drop it into the color zone, the effect is the same. So it's really the same thing, okay? But I want to be able to, don't just, take the color, take the SAT math out and drag the SAT verbal in. I want to be able to easily switch between different variables, right? And have the map highlighted for me according to these variables. So I can go ahead and do the column switcher. So how do you do column switcher? Go to the red triangle menu, right there. Red triangle, okay? And go ahead and do the, click on the redo close to the bottom. And the first thing that you will see is column switcher, right? Red triangle, redo, column switcher. Click. And it says, which column would you like to switch? Right now you have two things plotted, right? You have state, which is the map, and also SAT math. So which one do you want to switch for something else? Well, I want to switch SAT math. And then I click OK. It says, fine. What do you want to switch it for? Well, I want to be able to go back to SAT math, so therefore I'm going to say SAT math. How do I highlight multiple things? Control, right? I hit Control, and I want to be able to display SAT verbal. And let's do this one. Percent taking 2004, because it may or may not give us some insights, okay? Do you really believe that people living in the middle of the country are so much better than you in SAT, math or verbal? Probably not, right? But the map clearly says so, right? Maybe we'll find out why. Who knows? So let's click OK. And here is my column switcher. It says, well, right now I'm displaying SAT math, right? So if I click on the SAT math, nothing happens. Not a big surprise. Well, remember the previous chart that we did was the line, right? What does the line tell us? If the SAT math is low, SAT verbal is also low. If SAT math is high, it's also high, right? So if I switch to the SAT verbal, do you expect a different coloring on the map? Probably it's going to be the same, right? Because high states are still high in verbal as well, right? And low math states also low in math, right? So let's do that. I'm going to switch to SAT, from SAT math to SAT verbal. And what do I see? I see pretty much same thing, right? Now, of course, colors changed a little bit. It's a different variable, right? But the pattern remained unchanged largely, right? States that are in the middle are doing still well on the SAT verbal part, just like they did on the math part. And states on the coast, east or west or Alaska or Hawaii, they're not doing so great, right? Well, let's take a look at the percentage taking. Percentage taking looks a little bit different, right? So again, what's the best and what's the worst? Blue or red? Blue is the worst because it's low percentage taking, right? And red is the best because it's high percentage taking, right? So, what do you see?
Places where it's get less got higher scores.
Yeah, places where less percent of people took SATs, right? That's basically the central states, right? They got higher scores. On the coast, right? On the East Coast, for example, the percentage of people taking SAT was the highest, and they scored not so high. So, what does that? Does it give us any insight? What can happen? What could possibly have happened here?
The people who are driven to go to college are going to take the test and therefore score pretty well.
Yeah, possibly people who basically have a natural, I don't know, propensity, right, for studying, or they come from parents who are educated, so they had the, chance to talk to them, right? Possibly, that's one explanation. Any other explanation?
I was just saying, when there's more people, there's more stuff to more data to look over and everything. So maybe with more people, that made it, there was an error going over it maybe. So it kind of I guess it goes with skewing it and everything. But I was feeling it's hard to look over when you're not looking at people taking it versus when you have a few hundred people taking it.
Yeah, it could be, depends on the population, right?
Yeah.
Pretty much that's what you're saying. Yeah, it could be, because the majority of people in the United States, as you know, where do they live? On the coast, right? It's either East Coast or West Coast. Not a lot of people live here, right? So mountain area, Montana probably is one of the least populated states, right? Alaska is also very unpopulated state, right? I believe it's less than a million people actually in Alaska. What could also happen is it possible that these states reported only their top performers? Possible, right? To make statistics look, nicer, they're going to say, you know what? Number of people or percentage of people taking SAT probably doesn't vary a lot from state to state, right? Probably same percentage in different states, right? But it could be that some states decided to report only their top performers, right? And what did that? What kind of result did they get? Well, first of all, it looks like their percentage of people taking SAT is lower because they didn't report everybody, right? And because they reported only top performers, the results turned out to be inflated, right? If they would have reported everybody, it could have been a different picture, right? The percentage of people taking could have been higher, and the results could have been lower. But because they cut out people who didn't score that high, it made them look better on the SAT scores. But because it was underrepresented in terms of percentage of people taking. Is that a possible explanation? Yeah, could be one of them, right? So you can see that visualizing data can help you to gain some insight and start speculating what potentially could have happened, right? Okay. Another thing that I wanted to show you is this is a column switch, right? So I can switch between different variables and display them on the same chart, right? Also, what I can do is go to the red triangle, graph builder, right there. In the graph builder, go to the red triangle, and do this one, local data filter. What does that mean, filter? Filter means that we have an option to not display everything, but filter out certain data, right? And display only subset of data. That's pretty much what that means. So how about that? I'm going to see what does that mean, region, right? And try to filter on the region. So if you click add, okay, and then I'm going to show you also data filter for a continuous variable. So I decided to filter on the on the region, right? Region is what type of variable? Continuous or categorical? Categorical, right? And you can see that there are, what, 8 regions, right? So if I go ahead and click on, for example, south, all right, the map is modified. It filters out information just pertinent, relevant to southern states, right? I can, of course, select multiple of them, right? I can select Midwest and then mountain area. So it just basically expands the map, right? Every time when I click on something, it expands the map. So let's go ahead and clear the selection so that it displays the entire map. You realize the idea, right? You understand the idea behind the filtering. Local filter basically just adds the way to filter out some of the data, okay? Let me go ahead and add another data filter, okay? So how about I go to the graph, remove that one, and I go to the graph builder again, red triangle menu, and insert another data filter. The previous one that I selected was on the categorical data, right? Okay, so how about I'm going to filter things based on the numerical variables, such as, let's do the SAT math for crying out loud, right? So I'm going to do the SAT math. And look at that. There is no list anymore because the variable is continuous, right? Categorical means there is a list of categories. Simple as that. I can switch between them. Here, there are no categories. It's a number, right? But there are 2 sliders. One of them on the right, another on the left. And these sliders tell you within what boundaries you want the data, right? So right now, it's wide open, so it filters out everybody. So how about, for example, I'm going to start filtering out low numbers. So I'm going to take the lower slider and start moving it, okay? And as I move that, what happens? More and more states are getting filtered out, right? So I'm saying that, hey, I'm going to, for example, filter out all states that are below 500. So can I get a 500 on the low end? You know what? Even if I can't, I just click there and type 500. 500. Bam. So it just basically shows me only states that are scored on the SAT math higher than 500, right? And if I start moving, for example, upper boundary, then it starts filtering out states that did too well, right? So let's say, for example, I want to filter out and show states who scored between 5 and 550. Okay, so type 500 and 550. Kaboom, and that's it. And that's how the local data filter works. Fairly straightforward, right? Any questions, ladies and gentlemen? Simple, right? Easy. One click or a couple of clicks and you got yourself a very powerful visualization. Okay, now let's do something else. And we have 10 or 11 minutes. No, it's actually 14 minutes. Oh, good. That means that maybe we'll start talking about Tableau, right? We'll see. Okay, now I'm going to click Done and just close this, this chart, all right? Let me show you something that's called bubble plot, okay? Bubble plot, well, let's use the same data set, okay? Bubble plot also allows me to, it's a bivariate chart, really, okay? So it allows me literally to plot variable x against variable y. How did we call variable x against variable y if both x and y were continuous? My x is a continuous variable and my y is a continuous variable. And we just basically throw a lot of dots. We call it scatter plot, right? Now, what I can do extra with the scatter plot is I can use a point to represent more information. So essentially, it's a way to squeeze more data or information into your chart, okay? I can blow up the dot into the bubble, so the size of the bubble will represent something else, okay, for me. And also, I can color the bubbles, and color can represent something else, right? So I can add 2 more dimensions, so to speak, to my chart, right? So let's do that. Let's go to the graph, use the same data set, right? And you see that bubble chart, bubble plotter is a separate option for that, right? So go ahead and click on the bubble plot. All right, there it is. So let's kind of build it up from ground zero, okay? Let's see what happens. So I want to get my good old friend that I actually saw already. I'm going to use my SAT math as x and SAT verbal as y. We did that before today, right? We plot the point, and we saw that there is a straight line, low SAT math, low SAT verbal, high SAT, etc. And let's just go ahead and click OK, and this is it. Okay? I saw that plot before, right? Today already. So there is a straight line that connects them. Cool. But and there is a slider that allows me to control the bubble size. But right now all the bubbles have the same size, right? Because I didn't tell the bubble plot builder to do anything as far as the bubble size is concerned, right? So all the bubbles, they're basically the same size. All right. Now I want to add a little bit more information. So let's go ahead and I'll show you one more capability of jump. Go ahead and close that one. Okay. Close that one. And go to the graph. Do the bubble plot again. If I want to redo my analysis or set up for the analysis, there is a button called recall. Go ahead and click on recall. Last thing that you did, and it concerns any any type of analysis. It can be graph builder or tabular summary builder or anything, right? Fit y by x distribution. If you hit the recall button, it will fill in the things that you did the last time. Okay. Now what I'm going to do is go ahead and take the region, okay, and drag that into the ID area. Let's see what happens. Okay. Region into the ID area. Let's click OK. Look at that. So what happened is, how many points did I have before, if you would have to guess? 50, right? Basically, it plotted me the 50 different states, right? That's probably what happened. Maybe more, actually, if it plotted me all different states for all different years, right? Maybe more than 50. So, but yeah. Right now, what I have is actually... How many dots? I have 8 dots. Why 8? Because there are 8 regions. Remember, we did the local data filter with regions, right? There were 8 regions, right? So right now, what I have actually is my data that was originally in the state is kind of summarized by the region, right? And every dot represents a region. So let's take a look. Is there a tooltip? Yeah. So 56 records. You know what? You're probably right. It's not just 50 points. It's more than 50 because look at that. I'm looking at mountain region and it says 56 rows. Can it be states? No, there are only 50 states, right? So apparently what happened is this is the summary across multiple years, right? We have multiple years going on. This information was collected for the year like 1994, 1996, 98, etc. Right? So all the years, they were aggregated in one plot and then aggregated by the regions, right? So one dot represents all the states in this region and all the years that we have in the data file. Okay? All right. Now, what I'm going to do is also, let's see, let's go back. So I'm going to close out this one and go again. Graph, bubble plot, and recall, and it will remember my configuration. Now, I want to show the time, how it was evolving over time. Okay? So, and time is represented by what variable in my data set? You would have to guess. Year, right? There is a year. So I'm going to take year and put it into the time area. And also, let's see what happens. We're kind of going to slowly build it up because we're still kind of have 8 minutes to kill. We're not going to be able to start Tableau, unfortunately. So let me kind of prolong this pleasure, okay, of dealing with bubble plot. All right. So you click OK, and I have the same thing, right? Same thing. My SAT math versus SAT verbal, summarized by the by different states. Okay, and what I have also is this play button, right? So let's go ahead and click that play. Look what happens. You have a time index right there going forward, right? And you can see the history, how it all progressed from the year 1992 to the year, what was last, 2007 or something like that? 2004? Yeah. Isn't that nice? This is an animation, right? It basically shows you how states, or regions in that case, right? We don't have states, we have regions. How in different regions, the educational system was changing, right, over time. And what do you see? Overall, what kind of movement happens?
Positive.
things are getting better, right? So from 1992 till 2000 and what was the last one? Yeah, 4. Most regions moved. Some moved quite a bit. Some moved slightly, right? But SAT is going up and verbal is going up. So apparently, it was a positive trend overall, right? Now let me illustrate a couple of more things, okay? Let me go ahead and close that one and go back to the graph, bubble plot, recall. I didn't use size and I didn't use color yet, right? So how about that? I'm going to be simplistic. Take the region and put it to the color. So therefore my dots are going to be colored differently for different regions, right? Simple as that, okay? In no specific order, it's just a bunch of 8 dots colored in 8 different colors, random colors, pretty much, okay? But let me go ahead and make them size based on, do you remember our finding that percentage of people taking was different from state to state, right? State that showed good performance in terms of SAT, the percentage of people taking was low in them, right? Another way around, states at the bottom, they showed highest percentage taking, right? So let me go ahead and size the dots according to the percentage of people taking the SAT in this region, okay? So I'm going to take percentage, where is that? Percent taking 2004 and drag it into the size, okay? And drop it over there. Let's see what happens. Well, first of all, you can see that there is a nice kaleidoscope of colors, right? So 8 regions colored in 8 different randomly assigned colors, right? But also what you see is just like what we saw on the map, right? When we switched between columns, we saw that high SAT scores on math or verbal translated into low percentage of people taking, right? My size, and my title even says so, right? Bubble plot sized by percentage taking. So therefore, the regions that were highest in terms of the SAT scores, the bubble is smallest, right? Why? Because these states, these regions had the smallest percentage of people taking the SATs, right? And at the same time, at the bottom, you can see that these bubbles are largest, right? That's because they were at the bottom of the SAT range, right, on both SAT and verbal, but they had highest percentage of people taking the SATs, right? So that basically explains the colors, okay? And then I click OK. Oh, the run button, it just basically shows how these things progress through time. Is that cool or what? Extremely cool, right? How do you like them apples? Very powerful stuff, right? Can you do that with Excel? I'm guessing you can, but it requires quite a bit of behind-the-scenes programming. Excel, natively, if you go into the Excel interface and start building these charts, first of all, I don't think that Excel can do bubble plot, can it? Can do bubble plot, probably, right? Can it do maps? Not that I remember, right? With Excel, you can do, I mean, don't get me wrong, Excel is very powerful, and probably no matter how far we go with our visualization tools, Excel will never going to go away, because Excel is, I read somewhere, somebody said Excel is the second best thing to do everything, okay? So there are programs out there that can do killing visualization. Excel can do it too, okay? There are programs who can do it better, but they do exclusively visualization. Okay, you can do the spreadsheet modeling, right? There are programs, specialized programs that can do that type of analysis with the killing accuracy and a lot of different options, right? Excel can do that too. So the power of Excel is that you can build simple models and with very rich functionality, very rich features, right? But for everything that Excel does, there is a better program out there that does that thing with a bigger data set, with more options, more features, better, right? So these charts, these plots, Excel probably cannot do them, and God, you can do visualization with Excel, right? So Excel is pretty much, poor relative in the family of the visualization programs. Well, you know what? What we're going to do also, I will show you probably another tool. We're pretty much done with JMP, with visualization in JMP, okay? So next class on Wednesday, we're going to take a look at Tableau, all right? I'm going to check actually if Tableau is installed on these computers. And after I show you the rich functionality of Tableau, I'll show you another program. We're not going to do a lot with it, but Microsoft actually realized that Excel is not living up to the expectations of people who want killer visualization. Okay, and Microsoft created a rival product for Tableau, which has very similar functionality. It's called Microsoft Power BI. Microsoft Power BI can do also really cool charts. I actually showed you a couple of them. Remember the map that I showed you one day? People who applied to School of Business from the freshman year, where they're located geographically. That was done in Power BI, okay? What's good about Power BI is it's much, much cheaper than Tableau, okay? And what's even better, everybody can get it for free, the desktop version, okay? And I'll show you, I'll send you the link later on, okay? Where you can download and start playing around with Microsoft Power BI. So this way, after this course, you will have multiple tools under your belt, which you can put where? On your resume, okay? Okay, so we're done for today. Unfortunately, didn't get to Tableau, so it's going to be next class.